Welcome to GDB, the first and last debugger that you will ever truly love. On the left here, you can see that GDB's logo is the archerfish. It is an archerfish because the archerfish shoots down bugs. When you master GDB, you too will know how to shoot down bugs, and that is what these videos will teach you to do. GDB is really powerful, and because of that, it's used in a lot of software. So for instance, in Xcode, if you're debugging any C or C++, then it'll use GDB as the debugger. If you're using Eclipse's C plugin, it'll be using GDB. If you use Emacs or a plugin with Vim, you can use GDB. Pretty much because GDB is so powerful, everybody wants to use it. And you will regret using some big GUI debugger once you learn how to use and love GDB. Now let's jump right in. Here you can see that we have one file to compile, segfault.c. It's called segfault.c because it has all of the bugs that I could think to add. The first thing you need to know is how to compile it to use the debugger. If we just compile it with GCC regularly, then even though we can use GDB on the resulting file, you can see that it says no debugging symbols found. What that means is that if you try to debug it, all you'll have is assembly code. And that might be what you want if you want to debug an assembly, but for the rest of us who don't know assembly by heart, you'll want to compile with debugging information added. To do that, you can use the -G flag, which says compile with debugging information. If you use that on segfault.c, and then we GDB the resulting file, then you can see we don't get any notice that says no debugging symbols were found. It'll just go in there, and we can do whatever we want. For the rest of these videos, however, we won't just be using gcc-g, we'll actually be using a makefile. So you can see here we have a makefile, and instead of just doing the regular -g, we use -g3, which says compile with level 3 debugging information, which is basically saying instead of compiling it so that all debuggers, even ones that aren't GDB, will be able to use it, we'll compile more expressive information that GDB will be able to use. And gdwarf2 is the executable debugging file format that GDB uses. And this will let you do things like even use preprocessor macros, which you can't do if you just compile with regular -g. We're also compiling with -O0. O is for optimization, 0 is for none. We compile with no optimizations in order to make sure that the debugger won't kind of look at the code and think that the code is doing one thing, even though it was optimized to do something else. To use a makefile, we just say make, and then it prints out some messages about what commands it's running. And you can see instead of an a.out file, or the a.out file that we had from before is still there, but aside from that a.out file, it makes a file called segfault, which is what we want. Now we can debug segfault, and that'll be a lot simpler than if we had to go into a.out. Let's start debugging it now. The first thing that we have to do whenever we're debugging something is run it. Let's just try running it to see what happens. You can see here we type the character R, and that will run it. You could also type the command run, but that would work, but GDB knows how to shorten things. So in other words, even though you could type run, you can also type R. And in this video, I'll mostly be using the one-letter version of commands, or the shortened version of commands. So if we run it, it says the correct usage is segfault test. This is something that's just a part of the regular program. And so if we want to print out the basic test, we say rbasic. In other words, whenever we want to pass a command, then we say R, which is run, followed by whatever we want to pass. This would be the same as if outside of GDB we typed segfault basic, and you can see it prints out the same thing. Let's go back into GDB. you can see that what it prints out is hello world, hello world, hello world, hello segfault. That probably means that there's a bug in the part of our code that prints out world. Since I haven't actually shown you the source code of this file, we can actually see part of the source code in GDB by using the list command. If we say list main, since we know that this program has a main function, since all programs that are written in C have a main function, we can press list main, and that'll list the lines of code surrounding main. So you can see it also does a few lines above and a few lines below. Let's put a breakpoint on main. We could say breakpoint main, but instead we can just say bmain. Now you can see it says breakpoint 1 at this address. This is the address of main in code. If instead we wanted to set a breakpoint on a particular line, we could say B87. Or if we wanted to specify the file, because we had a project that had multiple files in it, and even though we were in main right now, or in segfault.c right now, we wanted to put a breakpoint in foo.c, then we would specify the name of the file that we want to put the breakpoint in. So in this case, we want to put it in segfault.c, colon, the line number. So this would be putting a breakpoint right there. And we're not going to hit that breakpoint unless we don't pass in the correct command line arguments. You can use list in the same way. In other words, you can say list, and then you don't have to specify a function name. You can specify a line number also. So if we say list 87, it'll print the lines around line 87. So you can see what we want to do is print out the GDB basics. So let's list that. So in GDB basics, it prints an array, it prints a combined array, and then it combines the array, and the last thing that it does is prints out the array again. In print array, we can see that it prints out each of the elements in the array and what that element has. And you can remember above that this is actually where the issue happened. If we know that an issue happened somewhere, then we should probably set the breakpoint there so that we can go and explore why that issue is happening. So let's put a breakpoint on print array. Now, when we run the program, every time it hits a breakpoint, it's going to actually encounter that. And you'll notice here it says the program being debugged has been started already. Anytime if you have already said R for run, then if you try to run it again, or if you try to quit it, it'll prompt you to make sure that you're ready to close the program. So if you say yes, then it will close the program and then start it running again. So since we want to go up till this breakpoint, then we can say yes, close it, and start running it again. Oh, but wait, it didn't go all the way to print array because we set a breakpoint in main. What that means is that every time you hit a breakpoint, even if it's not the last one that you set, it's going to stop at that breakpoint. If we want to continue on to the next time we hit a breakpoint, then we can say C for continue. And you can see now it's in breakpoint 2 of main because we forgot to put in the correct command line arguments. So now let's run it again with the correct command line arguments. So R basic. And now it prompts us about starting it again, and we do want to start it again. We're at the first breakpoint, and we continue. And in fact, I was mistaken. We passed in the command line arguments correct the first time, but it stopped at this line anyways because this line wasn't directly inside of the failure case. So you can see now we're on GDB basics. If we continue again, then we're going to go to print array. Just to remind ourselves, let's list around the current line. You can see when I type list and don't specify either a function or a line, it'll list out the lines right around where you are. So here I was on line 26, and when I say list, it prints out above and below line 26. And when I say that I'm on line 26, what that means is that whenever you are on a given line, that line has not yet been executed. So the fact that I am on line 26 means that this for loop has not yet been executed. If I want to go down one line, then I can press N. and you can see now it goes from line 26 to line 27. If I press N again, it'll go on back to the for loop because it went there once. If I hit next again, it'll go in. What do you think will happen if I don't type N and I just hit enter? It does next anyways, because what happens is that if you don't type anything in, it just prints whatever the last line was that you did enter. So that's very useful if you want to step one line at a time and don't want to keep having to hit N. The same thing can work with continue. If you set a breakpoint in a piece of code that gets run a lot, then you can put that breakpoint there, hit continue once, and then just keep hitting enter to keep it continuing a bunch of times. And you can see also here it is printing the 2627. In other words, it's printing the current line that I'm on, but it's also printing the output. So when you're in GDB, it will still print out everything that would normally be printed out. It just also prints out what line you're currently on. What if we want to get some extra information? To do that, we can use P, which stands for print. Later on, we'll talk about how print is actually a completely versatile command that you can use to execute absolutely any line of code that you want to, but for now, we will just use P to print out variables. So if we say pi, then that will print out the value of I. Disp, which stands for display, is the same as P, except for it does it every time. So if we disp I, then that will print out I every time. What that means is that if I say next, it'll automatically display what I is. Let's keep going through. So you can see we got a segfault when I was equal to 7. That probably is signaling to us that because array size is 7, and arrays are indexed starting at 0, that we were trying to access array index 7 when the array only had 6 elements in it. In other words, by using disp or print, next, and setting breakpoints and continuing, we were able to find out that our issue was that, in fact, here we have a less than or equal to array size instead of less than array size. Now that we've identified that very first bug, we can quit out of GDB by using the Q command. Q, it will prompt you that the program is running just like if you tried to run, and you can say yes, and now you're out of GDB. To review the things that we went over today, whenever you want to use GDB, you have to compile with -G, or better yet, -G3, gdwarf2. And you should probably be using GCC with this. If you want to print out some code where you are, then you can use the list command. And list will print out where you currently are, but if you want it to print out a particular line or a particular function, you can do that also. If you want to run the code, you just use R, which stands for run. If you want to set a breakpoint, you use B, which stands for breakpoint, and then you can specify the file if you want to. You can do this with list also, but it's less frequently used. And then you have to specify either the line or the particular function that you want to break on. If you've already started running it and you just want to go one line forward, you can use N, which stands for next. If instead of going one line forward, you want to go forward until the next breakpoint, you can use C for continue. If you want to print out some information, then you can use either P to print out something once, or you can use disp to print it out every line that you go over. So in other words, every time you hit N or C, it will disp something over again. And when you're all done, all you have to do is Q to quit out. And I've shown you how to eat your first set of bugs. Hopefully you thought that they were tasty, or at the very least full of protein. And if you stick with the rest of these videos, they'll get even better.